Hey, I'm Mr. Hayes. Welcome back to AP Statistics. We're going to start talking about simulations and the things that we need to have in there. So we're going to formalize it up here. These are kind of like the go-to notes. My classes, I'm having you guys, at least here during the pandemic, make sure you write these down in a separate notebook so everything is there in one spot. These are all from StatsMedic. Link is down below. If you teach stats, I'd highly recommend checking them out because it's really a much more fun way of teaching statistics, I would say. So, in terms of the important ideas, simulations, you need to have the following. Okay, as a definition, a simulation is an imitation of chance behavior based on a model that accurately reflects the situation. So, something like rolling a dice, a random number generator, if you have an applet that works, or if you know of an applet that works well, coin flips, putting things in a, randomly picking numbers out of a hat, whatever. All of that would be accurate or adequate ways of modeling a situation. Okay, you need to spell that out when you're designing or describing what your simulation is. You need to go ahead and make sure you lay that out. In terms of the simulation process, here are the three things you have to have in your simulation in order to get full credit. Okay, and not to be thought of as a loon in the statistical community. Simulation process: describe how one trial or repetition will be simulated. We did that. We're going to roll the dice. A 1 is a win. 2 to 6 is a lose. Okay, so you define it. Then you're going to go through do that many, many times because we want to see what happens in the long term. Remember, we had that thing called the law of large numbers last time. Instead of it fluctuating back and forth, when you do lots of different numbers, it's going to eventually tail off and start to kind of get really focused in on a number. And as we said, that's kind of like limits if you've done calculus. And then number 3, use the results to answer the question. So then you're going to see what you're seeing and you're going to compare it to what's going on. And then you've got that 5% number there. Okay, and we're going to formalize this more as we go down the chapter, but that's the basics. You need to have those 3 things. Okay, we have a question down here to go through about Wheel of Fortune. Some people have wondered if the Wheel of Fortune wheel is fair. If it is fair, the bankrupt happens about with a probability of 1 out of 9. To test the wheels, for those of you guys who haven't seen it, there's, I believe, 3 little stopping points for each one of these wedges. So this would be 3. Down over here is another 3. Up over here is 2. So there's that. Anyway, to test the wheel, Pat Sajak observed that a random sample of 50 spins of the wheel found bankrupt happening 10 times. Is this convincing evidence that bankrupt comes more often than it should? So take a second, work through these problems, and we'll check them here in a second. So, was Pat right? Or what did Pat see? So the first thing that we're going to do is up here, describe how one trial worked. We're going to use a random number generator to get 50 numbers from 1 through 9. Why 1 through 9? Because it's a 1 out of 9 chance of happening. So we're going to say 1 is a bankrupt, 2 through 9 is some other count, or is some other value, I guess. And you're going to count the number of ones. You can make it whatever number you want. Ones make it easy to find. The second step, perform it many times. We're going to do this many times to estimate the probability of getting 10 plus bankruptcies. So here, it's kind of doing 2 things. We're going to do this many times, and we're going to do this so we can estimate the probability of getting 10 or more bankrupts. All right? Obviously, you should probably say how many times you're going to do it. But down here, let's say we did it 100. Okay? So this is a simulated sample of bankrupts. So over here, this one point here, the question here is, what does that represent? So what that represents in one simulation of 50 spins, we got 12 bankrupts. This point over here, in one simulation of 50 spins, we got 3 bankrupts. This point right here, in one simulation of 50 spins, we've got, what did I say, 6 bankrupts. Okay, each one of those points is a simulation. That's a good thing to keep in the back of your head. Okay. So then from there, the question is, what conclusion can you draw? Assuming that the wheel is fair, there's about a 4% probability of getting 10 or more bankrupts in 50 spins. Because this is unlikely, meaning it's less than 5%, we do have convincing evidence of an unfair wheel. Do I need to write all of this? You betcha. Why? Because you're pointing out what's the situation. Assuming the situation that they're explaining, this is what we see. okay? And you're going to spell out, how many times you were spinning it, et cetera, all right? Because this is unlikely, so you're going to then point out saying it's not meeting our benchmark, then we have or don't have convincing evidence, all right? You need to have all those parts, and we're going to spell that out more as we go. So that's it for Wheel of Fortune. Thanks for coming. Vanna says goodbye. I say goodbye. Even Pat says goodbye. So we'll see you soon. But as always, if you have questions, shoot me an email, point them down below, like, subscribe, do all that other good stuff. And we'll see you soon.